Hi friends, going on with the JavaScript series, today I want to talk about fractals and recursion. So, what is it actually a fractal? According to the definition of the creator of fractals, Mandelbrot, a fractal is a rough or fragmented shape that can be split into parts, each of which is, at least approximately, a reduced size copy of the whole. So every part of this shape is going to look like the whole thing, no matter how much you zoom in. This is always theoretically speaking. But there's also another fundamental component that defines a fractal, and it is that every fractal has a recursive definition. So in order to understand and create fractals, we first have to understand recursion. According to Wikipedia, the definition of recursion is a function that is being applied in its own definition. So if we want to think about that in a linguistic way, it's like if someone asks you, what is an house? And you answer, well, an house is what an house is. So you are using the definition of an house while defining what an house is. And we are going to see how to apply this in code. So let's see a practical application of recursion in code. We are going to calculate the factorial of a number. So the factorial is a typical operation that can be performed by a recursive function. The definition of factorial is that this is the mathematical syntax. So it's that you multiply a number for all the integers less than or equal of itself. So, for example, if we take the factorial of n, we have n multiplied by n minus 1 by n minus 2, where is it gone, by n minus 2, multiplied by n minus 3, and so on, until you multiply by 1. And so this is the factorial of a number. For example, the factorial of 3, if we take 3, it's equal to 3 multiplied by 2 multiplied by 1, which is equal to 6. So let's create our actual JavaScript factorial calculating function. Let's create our JavaScript file and let's call this recursion.01.js. Can't find the file, of course. Let's give this the AutoWatch attribute. So this is going to be compiled anytime we save here in Sublime, as we said in the previous tutorials. And so let's now work with Sublime. Let's open the file, and there it is. Okay. So let's first calculate our factorial with not with a recursive function, but with a simple for loop. So let's create a function factorial, and it takes a number, and let's create a variable which is equal to 1. Let's create our loop 0 less than n, and e++ f is going to be equal to f multiplied by e plus 1, and then after that we can post f, our result. So this is simply the formula that we saw before, but reversed. So we start from 1 and we go up to the number and multiply every time the number to itself plus 1. So, for example, the first time, if we do the factorial 3, The first time f is equal to 1, and is going to be multiplied by e is 0 plus 1, so this is just going to be equal to 1. The second time f is equal to 1, but this time e is equal to 1, so it's going to multiply by 2, and f is going to be equal to 2. And then now f is equal to 2, and is going to be multiplied by 2 plus 1, which is 3, which is 6, which is our final result. And let's now calculate our factorial function in a recursive way. So let's comment out this function, and let's write a new recursive one. So factorial n. And in recursive function we always need an escape case, which is a case that allows the program to exit the function. Otherwise the function will just run forever. So our exit escape in this case, if it's n, it's equal to 0. So if n is equal to 0, you're going to return 1. Because 0 factorial is equal actually to 1. So this makes sense. 0 factorial is equal to 1. So if n is not equal to 0, we are going to return n multiplied by, attention, our function with n minus 1. So what is going on here actually? We are calling this function inside its own definition. So let's see if this works. First of all, to use this function we have to create another function, post result, and pass it to the argument, the number we want to factorial, and let's say post factorial of n, so this will post the result. And let's do this way to go to the other line. So instead of write post like that, we can just write also plus n, new line. So let's see. Oh, of course this is not going to work. Post factorial, no, sorry, post result 3. See. Well, yes, it's working. So let's see how this works. First of all, this is our function definition. So let's see what are the steps that the program follows when it's going to evaluate this function. So first of all, we call this function with n equal to 3. So it's not equal to 0, so we go to the else case. Now n is equal to 3, we are going to call this function with n minus 1, which is 2 in this case. So what happens? The program, Javascript, puts a frame on the stack. The stack is like a pile of data that is created when the program runs. So JavaScript puts this frame on top of the stack and is storing into it that n is equal to 3. And then it's going to execute the function again. So, but this time n is equal to 2. So let's see what happens. JavaScript puts another frame on the stack where n is equal to 2. So is storing in memory that at this point of the execution of the function n is equal to 2. So let's see. Now n is equal to 1. And now the third frame n is equal to 1, and factorial is going to be executed with n equal to 0. So in this case, the first case is met and it's equal to 0, so the function is going to return 1. And at this point, The stack is going to pull out all the frames from the last one, from the one that is on the top. So the factorial calling here is going to be replaced by the result of the previous calling, which is 1, and is going to be multiplied by 1. So the result is 1, and this result is going to be passed to the previous frame on the stack. Now the program is returning the result of this function to the previous frame in the stack. So n in this frame was equal to 2, so 2 multiplied by 1 is equal to 2. Now the function is returning this result to the last frame in the stack, so the first in order of time, and n in this frame was equal to 3, so it's going to multiply 3 by 2, and it's going to return our final result, which is 6. Now that I hope we have a much clearer idea of what recursion is in programming languages, let's do something more interesting with it. So let's take our objects from the previous tutorial. So the window, the render, and the sketch. It's just the same objects we used in the previous tutorial. And let's create a function that will draw recursively some circles. So let's call this recursive circles. And this takes an epsilon value, an x value, an epsilon value, and a radius value. So we need to use our sketch. First of all, let's set the shape slice to a big number so we get nice smooth circles. And then let's set the GL color to white since we have a black background. Then let's move the sketch to the position. So x, epsilon, our arguments are the position in which the circle is going to be drawn. And then let's actually draw the circle. So frame circle with the radius parameter. Now let's set our escaping condition. If radius is greater than 0.0.1, we are going to call again this function recursively. So, but this time the arguments are a bit different because the x value is going to be summed with the radius value, and the radius value is going to be reduced by half its size. Let's call this again, but this time for the left side, so x is going to be reduced by the radius, and the radius is also going to be divided by 2. So when the radius is smaller than 0.01, this function will exit. So let's also create a function draw to draw our window, my render point raise, my render point draw swap, and then let's just also reset the command line, the commands in the sketch object. So we are not going to animate this, we're just going to draw it once. So let's call the draw function, and we need also to call the recursive circles function. Let's start from a big circle in the center, so 0, 0 is the center of our window with the radius of 1. Let's see what comes out. Yeah, so these are our recursive circles. Well guys, I hope that was interesting enough for this recursion tutorial. In the next one, we are going to see some more advanced recursion, some object-oriented programming, some some utility creations, and we are going to see recursive trees, more fractals. So there are some things that we can see. So see you next time. Ciao guys.